Hello students, and welcome to our lesson on place values, naming numbers, and rounding numbers. So we're going to dive straight into it. Place values are important because they tell us what a number is actually worth. So each digit in a number has a value depending on its position in the number. All right, and the chart here shows us from right to left what the growing place values are. So we start real basic. If we just have a single digit, that is worth 1. A two-digit number takes us into the tens place. Then we have the hundreds, thousands, 10,000s, 100,000s, millions, and so on. So for every period, which is every group of 3 numbers, we go from ones to tens to hundreds. But once we get past the first period, we don't call the one spot in the next period 1 anymore. We just call it whatever that period is named. So in this case, thousands, then millions, then billions, then trillions, all the way up. But the idea is that wherever a digit is placed, it is worth whatever the digit is multiplied by that place value. So let's look at number 1 real quick. We're going to use the chart to help us. It says in the number 4,382, the 4 is in the blank place, so it represents blank. So what I'm going to do is I'm going to write those 4 digits in my chart. So 4382. So now the 4, if we read the chart, is in the thousands position. So over here in my answer, I'm going to say the 4 is in the thousands place. And that means it represents 4 times 1,000, which is 4,000. So the place value tells you what to multiply the digit by. So the thousands place with a 4 is worth 4,000. Next number is the 3. If we look at the chart again, the 3 is in the hundreds place. So we can say the 3 is in the hundreds place. So it represents 300. Next one, the 8 is in the tens place. So it represents 8 times 10 is 80. And the 2 is in the ones place. So you don't have to actually multiply it. We just multiply it by 1, which doesn't do anything. So it just represents 2. All right, let's try it with a bigger number though. So the next number is 465,910,382. In order to use my chart, I need to write all the digits in their appropriate places. So since I already used one row of the chart, I'm going to write it right below. All right, so now when we look at this number, the 5 is way over in the millions spot. Okay, so I'm looking at the chart where the 5 is and lining up with this word millions. That's its place value. So since the 5 is in the million spot, it is worth 5 million. The 0 is in the thousands place. So that means it is worth, hey, kind of a trick question. You might think it's worth 0,000, which is true, but 0 times anything is just 0, so it's worth nothing. Okay? Technically, we are multiplying 0 times 1,000, but because it's a 0, it's just 0. It's not worth anything. Okay, next one, the 8 is in the tens place, so it is worth 80. And the 9 is in the hundred thousands place. So it is worth 900,000. All right, so the place value tells us exactly how much each digit is worth. So now let's do a little puzzle. All right, we're gonna read it once, and that's gonna allow us to figure out how big the number is. And then we're gonna put all these place values in their appropriate spots. And this is just to get you familiar with the names. So it says, write the number that is described. The digit in the tens place is a 6, and the digit in the millions place is 6 as well. In the ones place, we find a 3, and in the 10 millions place, there is also a 3. Moving further, the hundred thousands place contains an 8, and the thousands place has a 9. The hundreds place is also occupied by a 3, and the 10,000s place is a 5. Finally, the largest value digit is in the hundred millions place, which is a 1. So because it just told me that the hundred millions place is the largest, that tells me that I need 9 place values. So 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3. And in case I didn't mention this yet, the commas are to make the number easier to read. they don't actually add any value to the number. So commas are technically unnecessary. They just make it a lot easier to read the number. All right, let's start going through this. So now that we know that we have 9 place values, now we can start filling things in. It says that the digit in the tens place is a 6. So the tens place is the second spot. I'm going to put a 6 there. The digit in the millions place is also a 6, way over here on the left. In the ones place, we find a 3. In the 10 millions place, there's also a 3. The 100,000s place contains an 8. That is right here. The thousands place has a 9. The hundreds place is a 3. The 10,000s place is a 5. And finally, that largest digit is a 1 in the 100 millions place. So you can see our number there, and we are actually about to practice naming numbers. So I'm going to save it for this next one. So how do we name numbers? So you've heard me say a couple numbers out loud, but I haven't explicitly taught you how yet. Numbers are read in groups of 3 digits that are separated by commas, where again, those commas make it easier for us to read the number. Each group, you heard me say this earlier, is referred to as a period, such as the thousands or the millions or the trillions, billions, so on and so on. The word and is not used when naming whole numbers. So for example, 105 is not, okay, not 105. Okay, this word and is not there. So 105 is just 105. There is no and. Okay, that is important because the and will represent the decimal place once we get to decimals. Just like think of money. If you have $10 and 50 cents, that word and represents the difference between dollars and cents, aka it's where the decimal place is in the number, $10 and 50 cents. But if you have $105 and 50 cents, if you say $105 and 50 cents, it just becomes redundant. We're using that word and far too much in everyday language. So you might hear people use the word and throughout, but technically speaking, there is no and unless you have a decimals place. All right, let's go name some numbers. So the trick to naming big numbers, I'm going to go back to the previous page for a second, is wherever there is a comma, you say the name of the period that just ended. So in this number, 465, comma, 910, comma, 382, everywhere I see a comma, I'm going to say what that period is called. So the 5 is in the million spot. So when I get to that comma, I'm going to say millions. Then when I get to the next comma, because it represents the thousands, I'm going to say thousands. Okay, so the trick to naming numbers is to say the period at the end of it. But otherwise, we actually only say 3 digits. So to say this part of the number, I'm going to say 465 million. Okay. Then I'm going to say 910,000. And sorry, by the way, I put an S at the end of millions and thousands, just million and thousand, no S there. But we are going to say million and say thousand when we get to these commas. That is the key to naming numbers. Otherwise, all you're actually doing is naming 3-digit numbers over and over again. Okay, one additional thing we need to keep in mind is the use of hyphens. So this first number is 42. So it's 40-2. Okay, it's a hyphen in the middle whenever we're naming a 2-digit number. As opposed to number 5, where we have a 3-digit number, this is 305 is 305, where there is no dash there. Okay, so we only use the dash for naming 2-digit numbers, but naming 3-digit numbers, we do not use the dash unless there is something in the tens place. So we have 40-2, we have 305 without the word and number 6, we actually have a comma in our number. So now what we do is we name what's in front of the comma. So in front of the comma right here is just a 7. So I write 7, and then I say 1,000. Okay, so it's 7, and when I get to that comma represents the thousands period. So it's 7,000. Okay, we can put a comma after 1,000, although it's not technically necessary. Usually we write commas after we've named the period. So 7,000, and then that 3-digit number is 416. 416. So 416. Notice this one, there is no hyphen, which is a little bit confusing for two-digit numbers. So this one is not technically part of the course in what I'm teaching you, but when we name here 42, it's 40-2. But 16 and the other teens all have kind of their own unique naming. So like 11 through 19 are all a little bit weird. They do not have hyphens in them. The rest of the two-digit numbers do, though. Okay, next one. Number 7, we have 62 in front of a comma. So I'm going to write 62 as if it was just the number 62. But then when I get to that comma, I'm going to name that period, which in this case is 1,000. So it's 62,000 and comma. 508 is 508. Number 8, we have 4 comma 005 comma 082. So I'm going to start with the 4 that's in front of the comma, which is just 4. But then I get to the comma, and that is in the millions period. So it's 4 million. Then I look at the next group of 3 numbers. I name these 3 numbers as a 3-digit number. So the zeros don't mean anything when we name a 3-digit number with zeros. So this is just 5. All right. So we have 4,005,000 because we get to another comma. And the last 3 digits, 082, are just 82. So 4,005,082. All right, and notice the hyphen between the 80 and the 2. Okay, last one. We have 70 and then a comma. So 70, that is 70. So 70, and because there's a comma there, I'm going to name the place value, which is million. Then the next 3 digits, 042, is just 42. So 7 million. 40-2, and when I get to the comma, I write 1,000. Then those last 3 digits, 310, 310. And we're done. All right, so why did we just do that? Well, we don't write checks very often anymore, so I'm not gonna make you think, hey, you gotta write checks the rest of your life, and that's when you're gonna write these out. The real reason is that I need you to know what a number is when I say it out loud. And I need you to be able to say a number out loud to me. So although writing it is very tedious, right? And like that took a long time just to name some numbers, we wrote it down specifically so we know how to say it and how to hear it. So it's not so much that I need you to be writing down numbers and words all the time, but verbally, we need to be able to communicate about numbers. So you need to practice saying numbers out loud. I cannot tell you how many times it happens where I say a number and I ask a student a question and they respond wrong because they didn't understand the number, not because they didn't understand the question. So we need to be able to communicate about numbers. The only way we can do that is if we both know how to name them, right? So we just did some naming. Now let's compare some numbers. All right, we are going to compare numbers by looking at the first place value from the left that is different. All right, we are going to use greater than or less than symbols. Okay, so symbol on the left is greater than, symbol on the right is less than, just to compare these sets of numbers. So all we really have to do is find out which digit from the left is different and say which one's bigger or smaller. If we say these numbers out loud, hopefully it's not too hard for us. We have 53,092 and we're comparing it to 52,978. So by saying them out loud, 53,000 versus 52,000, hopefully you see that 3 is bigger than 2. So we are going to have this as 53,000 is bigger. But the official way we're doing that is place value by place value. So the 50 part, the 5 in front, in the 10,000s place, we have a 5 in both numbers. So we don't compare those, they're the same. But the next digit is a 3 versus a 2. So in the thousands place, 3 is bigger than 2. So the left number, 53,000, is bigger than 52,000. So even though they started with 5s, because they were the same, we ignored that digit and we went to the next one. So you want to find the first place value from the left that is different. In number 11, we have 8,204,001 compared to 8,240,999. So notice the 8 and the 2 are the same, but then I have a 0 in the first number and a 4 in the second number. The 4 is bigger than the 0, so I'm going to say that the first number is less than the second number because 4 is bigger than 0. All right, so you're just comparing first number from the left that is different. Number 12, City A has a population of 425,310 people, while City B has 429,750 people. They both have 400,000, they both have 20,000, but then we have 425 versus 429. So the 5 and the 9 are the first place value from the left that's different. And since 9 is bigger, that means that City B is going to have the larger population. Number 13, a car traveled 382 miles and a train traveled 407. The first digit that differs from the left is the hundreds place. We have a 3 versus a 4. 407 is bigger than 382 because 4 is bigger than 3. And so which vehicle traveled further? We would say that the train traveled further here. Last one, a school has 1,248 students this year and 1,315 students last year. Is the school gaining or losing students? Well, they both have 1,000 something, but the first school has 1,200 and the second school has 1,300. So the second school, or sorry, not the second school, but the second year is bigger. Gosh, can I read a question, guys? Let me reread this for you. So we know that the second number is bigger than the first number, but it says that they have the first number, 1,248 this year, and 1,315 last year. So if they had more students last year, then this school is losing students. Okay, the number for last year is the bigger number, which means that they are losing students. Okay, last thing we're going to talk about is rounding. Okay, rounding is very important because we don't always want to be specific to 1,000,000 decimal places or to a lot of place values. So instead, we round to a convenient place. Now, let me warn you, you only get to round in this class if I tell you to. Otherwise, I expect you to tell me the exact answer. But there will be a lot of cases where we have a reason to round. All right, so to round a number, find the place value you are rounding to and look at the digit to its right. If that digit is a 0, 1, 2, 3, or 4, we're going to round down. And if the digit is a 5, 6, 7, 8, or 9, we're going to round up. And then we will replace all digits to the right with zeros. So number 15, we want to round 4,382 to the nearest thousand. So what we do is we look at the place value described. So since it says 1,000, I'm going to look at the 4, but then we're going to look at the number to its right. The number to its right is a 3. A 3 tells me to round down. So instead of rounding this number up to 5,000, we're going to round it down to 4,000. So what I'm saying is that this number is closer to 4,000 than it is to 5,000. Okay, so we round down to 4,000. Number 16, right below it, says round 9,982 to the nearest hundred. The hundreds place has a 9 in it. So we look one number to the right, which is this 8. The 8 tells me to round up. So that 9 that I'm pointing to is going to go up 1 and become 10. But when it becomes a 10, we have to add that second digit to the column to the left. And so this number is actually going to become 10,000 overall, where we rounded the 9 in the hundreds place up. But because this is a 9, when we round it up, we have to add it to the next column to the left. So 9 actually became 0 right here, but then we added 1 to what's next to it. So this 9 became a 10. All right, let's see another one. We want to round 927 to the nearest 10. So we're going to round to the tens place, which is the 2. The number next to it is a 7, so I'm going to round up. So 927 is going to round to be 930. Okay, 27 is closer to 30 than it is to 20. Number 18, we're going to round 75,609 to the nearest 1,000, which is where the 5 is. The number next to the 5 is a 6. 6 tells me to round up, so we're going to round 75,609 to be 76,000, where I turn the 5 into a 6, and I make the digits to the right all zeros. Number 19, we're rounding 241,367 to the nearest 100,000, which is where the 2 is. So we look one digit to the right, and it's a 4, so we're going to round down, which means we are going to end up with 200,000, because we are saying that 241,000 is closer to 200,000 than it is to 300,000. Number 20, we're going to round 6,995 to the nearest 1,000, which is where the 6 is. The number next to it is a 9. So 6,000 is going to round up to become 7,000. So now we're going to dive a little bit deeper into number 16 real quick. Our answer is perfectly fine. It does round to be 10,000, but let's see in a little bit more detail why. If I were to write this number out in expanded form, okay, 9,000 would be what our first digit represents. Then we're adding 900 to it because the 9 in the hundreds place. The 8 is worth 80, and the 2 is just worth 2. So we have 9,982 when we add those back together. And what we're doing is we are rounding to the nearest 100. So what we're doing when we round, when we have this expanded form like this, we want to round to the nearest 100, which is this 900 block is currently how many hundreds we have. So we look one digit to the right at this 80, and we ask ourselves, is 80 closer to 0 or closer to 100? Because it is an 8, we round up to 100. So instead of putting 80 here, I round this to be 100. But look at now when I put this back together. Oh, and by the way, 80 and the 2 just becomes a 0 because everything to the right becomes 0. But 80 becomes 100. Now, when I take that 100 and I add it to this 900, it becomes 1,000. And when I add 1,000 to 9,000, I end up with 10,000. Okay, so the reason that we end up with this kind of funny case where this 9 rounded up to be a 10, but that actually turned the 9 next to it into a 10, is because this 82 down here becomes 100, and when we add this 100 to this 900, it becomes 1,000, so it spills over into this thousands category. So when you have a 9 in the place value you're rounding up, it's always going to impact the place values to the left of it. All right, a couple more examples now, just real life. Why might we round? Well, sometimes we're going to do some calculations, but then we're going to round to make our lives easier most of the time. So for example, a meal might cost $52.87, so you might pay $53 with cash. A population of a city might be 47,982, but we would probably just say it's about 48,000. A table might be 197 centimeters long, but we would just say it's about 200 centimeters. So rounding is usually just for convenience. So just a couple examples of where we might round. If your exact grocery bill is $134.76, we might just say, hey, we're going to bring $135 in cash. We're not going to bring any pennies, so we're going to round up and bring $135 in cash. 22, if a town reports a population of 82,493 people, and it gets written in an article how many people they have, they might say that there's about 82,000, or maybe they would even just say about 80,000. Okay, so when we write this article, we might not be that specific and say 493. We might just say about 82,000, or maybe even just 80,000. It's close enough. And then 23, a car trip will use 11.7 gallons of gas. How much gas would you tell your friends is needed? Well, if you tell them 11.7 and you end up using 11.8, they're probably not giving you that extra money. So you might just report to them, hey, we're going to use about 12 gallons. So you might round up just for convenience to make sure they give you enough gas money. You also might round to be 12 just because saying 11.7's probably more specific than they care about, right? Even if it's true, 12 is probably good enough for them. So now I don't want you to get in the habit of saying things are good enough and not being exact, but I do need you to know how to round. That way, when situations present themselves, you are capable of doing so. All right, that's all I got for you guys in this one. Hopefully you enjoyed it, and now you know how to name some numbers.